All right, this is part 2 of the answer key to C12P. Again, the idea is that you've already done all of this, and at this point you're just checking your answers. You're seeing what questions you have questions about. So this should already be completed. Let's jump into it. We've got 10 is 2 times 5. 12 is 4 times 3, which is 2 times 2. So this is the third root of 2 times the third root of 2 times the third root of 2 times the third root of 3 times the third root of 5. Now we've got 2 times 2 times 2 times 3 times 5. 3 of those factors of the third root of 2 multiply up to 2 by the definition of what the third root of 2 is. We have these 2 other third roots, but they're not of the same number, so all we can do is multiply the radicands. All right. These weren't too bad to deal with because we had the same index, so they were nice to deal with it in terms of the radicals. These ones I'm probably going to want to deal with because we have different radicals. I'm going to want to deal with those or different indexes. I'm going to want to deal with those in exponent form. So I have 5 to the power of 1/3 times 5 to the power of 1/4, which would be 5 to the power of 1/3 plus 1/4, which would be 5 to the power of 7 over 12, which if I want to go back to radical form, I certainly can. It would be the 12th root of 5 to the 7th. All right. On the next one, it's a little bit tricky to deal with this in exponent form, so I'd prefer to deal with this in radical form. I've got the second root of 15 times the second root of 35, and now this is essentially the same question as number 7 was. We've got 3 times 5. Here we've got 7 times 5, so we have the second root of 3 times the second root of 5 times the second root of 5 times the second root of 7. These 2 second roots of 5, or square roots of 5, are going to make 5 when we multiply them together. We've got these 2 other square roots, which we can multiply together and get 21. So the second root of 21, if you want to write the square there, you can. If you want to write this back in exponential form, it would be 5 times 21 to the 1/2 power. All right, number 10. We've got, let's see here. How do we want to deal with this one? We probably want to go ahead and stay in exponent form here because it's not going to be too tricky. We've just got 7 to the power of 1/3 plus 2/5, which would be 7 to the power of 5 plus 6 would be 11 over 15. All right, check my arithmetic on that one. I'm not going to promise it's right. On the next one, how do I want to deal with this? Well, I suppose I would deal with this one probably by going to exponents, although you could do it by multiplying this by a bunch of, by 3 more copies of the 4th root of 5. I would probably just say this is 5 to the 1/2 over 5 to the 1/4. So this would be 5 to the power of 1/2 minus 1/4, which would be 5 to the power of 1/4, which would just be the 4th root of 5. Right. Now on number 12, I would probably just say, okay, well this is easy enough to see as the square root of 2 times the square root of 7 over the square root of 7. Square root of 7 divided by the square root of 7 is 1. So all I have here is the square root of 2. On number 13, I can just go ahead and deal with this subtraction, no big deal. I would have 3 to the power of 3/5 minus 1/2, which would be 3 to the power of, let's see, that would be 6 minus 5 would be 1/10, I believe. Double check my arithmetic, I'm not promising it's right. Ooh, yucky. Although on this one, I think it's actually going to be a lot easier for me to see this as radicals. And you don't necessarily have to go to radicals here, but I'd have the square root of 7 over the square root of 21. The square root of 21, so this is square root of 7, is just the square root of 3 times the square root of 7. So those square roots of 7 divide out. We're left with a 1 on top and a square root of 3 on the bottom, which I could write as 1 over 3 to the 1/2 if I want to keep myself in exponential form. All right, more solutions to the back of the page on the next video.